morning, students. Last class I told about three-dimensional geometry introduction and the points lies on x-axis, how we are writing their coordinates. If the points lies on planes, how their coordinates. Today we'll discuss about direction ratios and direction cosines. Direction ratios and direction cosines. In this, already I told about direction ratios and direction cosines in vectors also. This is similar to vectors chapter also. In case of direction ratios and direction cosines, how we are recognizing those direction ratios and direction cosines will form here. Take here z-axis, y-axis, and here x-axis. Here it is. O is the point of intersection of x-axis and y-axis and z-axis. All the three are here mutually perpendicular each other. Take one line segment here OP, and P is one point in the space here. At the same time parallel to one more line AB here. A, and it is the B here. Let the angles made by the OP to the x-axis in the direction of x-axis alpha, in the direction of y-axis beta, the direction of z-axis gamma. Then direction cosines of OP are given by with the help of cosine function cos alpha comma cos beta and cos gamma here. Here the angles made by OP, then we can consider those three angles also made by the line segment AB here, because AB and OP are parallel, at the same time they have same measurement here. That's what the angles alpha comma beta and gamma are made by the line segment AB also. Based on this concept, the direction cosines of OP are also considered as the direction cosines of AB, that is cos alpha, cos beta and cos gamma. At the same time we considered with some letters, it is L, M, N here. That's what here L, M and N are the direction cosines of the line segment AB here. Now we'll discuss about direction cosines of axis. Direction cosines of axis here. Direction cosines of axis. First one is x-axis. Direction cosines of x-axis, how we mentioned here. See here, if you can take angles on x-axis, already I told these three axes are mutually perpendicular to each other. That's what the angles on x-axis are given by 0, 90 and 90 here, because the angle on x-axis is 0 degree. At the same time the x-axis is perpendicular to y-axis and the x-axis is perpendicular to z-axis. Therefore the angles made by the x-axis to remaining y and z are 0, 90, 90. Then you apply these rules: cos alpha, cos beta, cos gamma. Alpha is equal to 0 degree, beta is equal to 90 degree and gamma is equal to 90 degree. Then you apply these rules here: cos 0 degree, next one is cos 90 degree, next one is cos 90 degree here. Cos 0 is 1 and cos 90 is 0 and cos 90 is 0. that is 1 comma 0 comma 0. Therefore direction cosines of x-axis are 1 comma 0 comma 0 here. Similarly, we can give proof remaining direction cosines of remaining two axes, that is y-axis and z-axis also here. Now y-axis, in case of y-axis, which types of values we are getting for direction cosines here? Now the angles on y-axis with to the remaining x and z are 90 comma 0 comma 90, because the angle on y-axis is 0 degree and it is perpendicular to remaining x and z axis. They are 90 comma 90. Just you apply cosine function here, cos 90, next remaining is cos 0, and next remaining is cos 90 here. Cos 90 is 0, cos 0 is 1, cos 90 is 0. Therefore direction cosines of y-axis are 0 comma 1 comma 0. Next one is z-axis. Even for z-axis also, the angles on z-axis, the angle on z-axis is 0 and is already perpendicular to remaining axis x and y. Therefore angles on z-axis we can take here 90 comma 0. The angle on z-axis is 0 and is perpendicular to remaining axis x and y. Therefore then we can write cosine values to all these degrees. Then we will get direction cosines of z-axis like this: cos 90 comma cos 90 comma cos 0 here. Cos 90 value is 0, cos 90 value is 0, cos 0 is 1. Therefore 0 comma 0 comma 1 are the direction cosines of z axis here. Like that we are finding direction cosines of axis. Even I told about all these conditions in case of vectors also, because we are applying those rules in three-dimensional geometry. That's what once again we are revising direction ratios and direction cosines here. Next one is some important notes, some important points will come based on direction cosines and direction ratios here, because we will use those formulas. We shall use those formulas for to solve some problems of 11.1 exercise. Now important formulas under the notes based on direction ratios and direction cosines here. Number 1 here, a line segment joining of the 2 points, a line segment joining of the 2 points P, x1 comma y1 comma z1, and Q here x2 comma y2 comma z2. Then direction cosines of PQ and direction ratios of PQ, how we are finding here? First one is direction ratios. Direction ratios here, a line segment joining of the 2 points P and Q. Then direction ratios, how we are finding here? Yes. Simple. If a line segment joining of the 2 points P, x1 y1 z1 and Q x2 y2 z2, then direction ratios of PQ are given by x2 minus x1, y2 minus y1, z2 minus z1. Like that we are going to find in direction ratios. How we are getting this these values means, according to vectors, position vector of Q minus position vector of P, then we will get these values. Like vector OQ minus vector OP, x2 minus x1 I cap, y2 minus y1 j cap, z2 minus z1 k cap. Like that we will get one vector PQ. In that vector PQ, we can collected that coefficients of I cap, j cap and k cap. Then those values are considered as direction ratios of PQ here. Second one is direction cosines. direction cosines here. Direction cosines of same here also a line segment PQ joining of the 2 points P here x1 comma y1 comma z1, Q here x2 comma y2 comma z2. Then direction cosines can be written as x2 minus x1 whole dividing by PQ, y2 minus y1 by PQ, z2 minus z1 by PQ, where PQ is the distance between the 2 points. Here we must and should take that distance of P and Q also here between the 2 points P and Q. We need a distance also when we are going to find in direction cosines of the line segment PQ here, where PQ is equal to here PQ is equal to square root of x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. It is the formula to find distance between the 2 points, because we need a distance also in the case of to find direction cosines of line segment PQ here. Next one is third condition is already I told about third condition also. If L comma M comma N, if L comma M comma N are the direction cosines, then we are always taking this condition, that is L square plus M square plus N square is equal to 1. Already I told about this condition in vectors also. That is how we are saying this condition in words. The sum of squares of direction cosines of any line is always equal to 1. That is L square plus M square plus N square is equal to 1. For example, you can take any vector, from that vector just you find all the direction cosines, just take sum of squares of all direction cosines, that value was always equal to 1. That's what it is the standard condition in case of vectors. That is and we are applying this condition in 3-dimensional geometry also. That's what we can tell about this condition is the sum of squares of direction cosines of any line is always equal to 1. Next, fourth condition. The condition for the 3 points, say capital A, x1 comma y1 comma z1, capital B, x2 comma y2 comma z2, and capital C, x3 comma y3 comma z3 are said to be collinear, is given by x2 minus x1 dividing by x2 minus x1 whole dividing by x3 minus x2 is equal to y2 minus y1 whole dividing by y3 minus y2 is equal to z2 minus z1 whole dividing by z3 minus z2. Like that, here important condition It is a geometrically important condition in case of three-dimensional geometry to show the given 3 points are collinear. 3 points are collinear means if all the 3 points are lies on the same line, like it is A, here B and here C. Like that all 3 points are lies on the same line, then we are calling those 3 points are collinear points. That's what, whenever show that the given 3 points are collinear, at that time then we have to apply this formula to show all the 3 points are collinear here. Next, fifth point. Just they will give only direction ratios A comma B comma C here. A comma B comma C. Direction ratios means here the numbers A comma B comma C are proportional to the direction cosines L comma M comma N. Then we are calling those 3 points are direction ratios here. How we are telling those 3 numbers are proportional to the direction cosines? Let us will discuss about this. A comma B comma C are the direction ratios here. Direction ratios here. Then direction cosines are given by here. Then direction cosines are given by A by square root of A square plus B square plus C square, B by square root of A square plus B square plus C square, C by square root of A square plus B square plus C square. Just to consider, this is L, this is M and this is N here. These are all direction cosines. When only they give direction ratios 3 values, with help of these 3 we are going to find in direction cosines with help of this formula, that is A by square root of A square plus B square plus C square, B by square root of A square plus B square plus C square, C by square root of A square plus B square plus C square. Like that we are finding direction cosines. But definition of direction ratios is the 3 real numbers A comma B comma C are proportional to the direction cosines values L comma M comma N. Then we are calling those 3 numbers A comma B comma C are called direction ratios. How we are showing that proportionality condition between direction ratios and direction cosines? Let us will discuss about that here. See here, one direction cosine value A by square root of A square plus B square plus C square is equal to some letter L here. That is A by, you consider this part is some K, it is equal to L. That is equal to A is equal to K into L here. That is A is proportional to the value L. If you are getting formula like this, A is proportional to the number L. That's what proportionality condition is there means, then we are calling A as the direction ratio. Similarly, in the same way, we can give proof for B by K is equal to L, where K is the square root of, where K is equal to what we considered here, square root of A square plus B square plus C square here. It is the A square plus B square plus C square, square root value. B by K is equal to M. Then B is equal to, we can take here K into M. That's what proportionality condition is there between the 2 numbers B and M. Therefore, B is the proportional to M. Therefore, B is the one direction ratio. Next, similarly in the same way, C by K is equal to N. Then C is equal to K into N. Here also proportionality condition is there between the 2 numbers C and N. That's what C is the proportional to N. That's what C is the one more direction ratio. That's what, based on all these 3 rules, we are giving definition for direction ratios is The numbers are the real numbers a comma b comma c which are proportional to the direction cosines L comma m and n. Then we are calling those three numbers a comma b and c are called direction ratios. Like that, this is the information about direction cosines and direction ratios. Already I told some important points under the notes because we are applying all these 5 important formulas in the case of to solve the different types of problems in exercise 11.1. Now let us will discuss about the problems in case of 11.1 exercise here. It's nice. First one is 11.1 exercise problems. Number 1. If a line makes an angles 90 degree, 135 degree and 45 degree along the x comma y and z axis respectively, then find the basis, then find direction cosines. Then find the direction cosines here. They'll ask here direction cosines. Just they gave 3 angles. With help of those 3 angles here, we have to find out direction cosines. How we are finding those here? Solution. Let the given 3 angles. Alpha is equal to 90 degree, beta is equal to 135 degree, gamma is equal to 45 degree. Then direction cosines formula. Already I told, whenever the angles are given means we have to apply cosine formula to get the values of direction cosines in case of 3-dimensional geometry. That's what here we have to apply cosine angle formula, that is cos alpha comma cos beta comma cos gamma here, cos 90 comma cos 135 degree comma cos 45 degree. Cos 90 value is 0, cos 135 degree value is minus 1 by root 2, cos 45 is 1 by root 2. Cos 135 degree, how we are getting minus 1 by root 2 means 135 lies in second quadrant. In case of second quadrant, cosine function is always negative. That's what the coming value also negative value with respect to 135 degree for cosine function. That's what we can write here, cos of 135 degree is minus 1 by root 2. Therefore, the values of direction cosines are 0, minus 1 by root 2, 1 by root 2 are the required values of direction cosines for the given problem. Let us now next question. Find the direction cosines if a line makes equal angles with the coordinate axis. If it makes equal angles, then how we are finding the direction cosines here? Find the direction cosines. Find the direction cosines. Find the direction cosines. If a line makes equal angles. With the coordinate axis, with the x comma y and z axis respectively. Here equal angles are there. That is we can take equal angles means alpha is equal to beta is equal to gamma we must take here. Solution for this question is in this question the line is making all the three angles and they must and should equal also here. That's what, based on that condition we can take those three angles are equal like this. Alpha is equal to beta is equal to gamma. Then you can take with respect to cosine function, cos alpha is equal to cos beta is equal to cos gamma, or you can represent with some letters. L is equal to m is equal to n also. Already we knew about one important condition with respect to direction cosines, that is sum of squares of direction cosines of any line is always equal to 1. We have to apply that condition here. By applying that condition we will get the different types of values for direction cosines here, like this. L square plus, consider L square plus m square plus n square is equal to 1 here. That is L square plus L square is equal to 1 here. 3 L square is equal to 1 here. L square is equal to 1 by 3 here. L is equal to plus or minus 1 by root 3 here. One pair is 1 by root 3 comma 1 by root 3 comma 1 by root 3. Another pair is minus 1 by root 3 comma minus 1 by root 3 comma minus 1 by root 3. Like that here we are getting different types of values. One is positive direction level value, another one is negative direction values here. Next one is, if minus 18, 12 and minus 4, minus 18, 12 and minus 4 are the direction ratios, then find their direction cosines. Minus 18, third question is minus 18, 12 and minus 4 are the direction ratios, then find their direction cosines here. See here, already I told one formula that a comma b comma c, a comma b comma c are the direction ratios, then direction cosines are given by a by square root of a square plus b square plus c square, comma b by square root of a square plus b square plus c square, comma c by square root of a square plus b square plus c square. Then here we have to apply this formula. See here, minus 18 by square root of minus 18 square means 324, 12 square means 144, minus 4 square means 16, 12 whole dividing by square root of 324 plus 144 plus 16, minus 4 whole dividing by square root of this formula here we applied. 324 plus 144 plus 16 here. Minus 18 whole dividing by 484. 12 whole dividing by 484. Minus 4 whole dividing by 484 here. Minus 18 by 484 value is square root of 484 is 22 here. 12 whole dividing by 22 here. Minus 4 whole dividing by 22 here. On gets cancellations you will get your 9 and 2 11s, 2 6, 2 11s, 2 2s are 2 11s. This is equal to, its value becomes minus 9 by 11, comma 6 by 11, comma minus 2 by 11 are the direction cosines of the required line segment here. Next class I'll tell you some different types of problems like this. Even when direction ratios are given, how we are finding direction cosines. When angles are given, how we are finding direction cosines. Like that I told different types of problems. Next class I'll tell you how we are showing the points are collinear, how to find out direction cosines and direction ratios when a vertices of triangle are given. Like that different types of problems will solve. Thank you very much.